Can you all see my screen?
Yes, ma'am.
Okay. 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 So, hi everyone. I am Manogna. I'm a PhD student in IISc. I'm currently working under the supervision of Professor Soma Biswas there. Uh, yeah. So I'll be one of the TAs for this course. I guess this is your first session for this course, right? Uh, Hi. Can you are hearing me, right?
Yes, ma'am.
Okay. So have you guys all watched the lectures for this course for this week's content?
Your voice is too low. Could you speak loudly?
Okay, wait. Let me try using my. Hello. Can you hear me now better? Okay. Let me know. Okay, if there's any issue or anything when I'm speaking. So have you guys all watched the lectures of this week? I mean this week's content, or how many of you have not watched? Okay, fine. So I have a couple of questions prepared, and I'll discuss them. These are based on the content of, I mean, this week's content. So while doing through it, we'll kind of review a few concepts as well. Let me know if that works. Fine towards the end of this class. So have you guys all? How many of you are like doing this course for the first time, as in anything related to image processing for the first time? Okay. So how are you guys finding the content of this course? Can one of you unmute and answer those who's raised the hands? Okay. Okay, yeah, you're in the first lecture, so it should be easy. It's a well thought course, so yeah, let's see. I just wanted to know for how many people it's very new, right? Like, so how was it to understand? So based on that, I can plan what kind of things to do in these live sessions from now on. Anyway, let's see. I'll maybe ask you guys towards the end of this session. You can let me know how this session went. So based on that, I can plan few. I mean, we can plan future weeks content or customize it as per the need. Okay. Hmm. So yeah, there are a few questions. I'll go over the questions. Maybe I'll pause at each question, like wait for people to answer and see, and then we'll discuss them and so on. You can still see my screen, right? Okay. So yeah. So anyway, yeah, this is a course on image processing. So it kind of introduces you to how an image is formed, how it is captured, like the sensors and all such stuff, right? So yeah. So what are the valid image coloring formats? Can someone answer based on the options given here? RGB, okay, and CMYK, yes, and Yes, RGB. Yeah, yeah, RGB and CMYK. I got two answers till now. Is that all? RGB. Okay. Okay. So, uh, yeah. So fine. RGB. I think as most of you know, because so RGB refers to the three channels where you get the red component, green component, and blue component, which put together can represent all the colors which we see. And what is the range of values each of them take? Do you know, is no? So what is the image dimension usually when we capture an image, right? So what is the dimension of that array? It is an array, right? So what is the dimension of that array? Say it's an RGB image. Um um, it, dimension, I mean, how many height width into 3, right? Yes. So in the case of RGBA, what would be the dimension? It would be 4. And what does that A represent? Transparency, right? Uh, okay. And do any of you know about this format CMYK? Okay, yeah, this is. Was someone answering? Okay, this format of like color representation is usually used for printing something on a paper. Uh, I'm not very aware of this, but yeah. So it basically models the printing process and takes into account that you're printing on a white paper, and based on that you get the components of cyan, magenta, yellow, and the last one K represents the black component. Yeah, so yeah, RGBA, and yeah, hexadecimal is also a color format. So if anyone has worked in design or anything, you can actually select like colors in hexadecimal format, right? These kind of formats. This represents white, and this represents black, all like all zeros, and yeah, has any of you used or like seen the color format in hexadecimal? Say when you're making presentations and stuff, you might have observed. Have you? Mm-hmm. Yeah, you can use a color when you're using color picker. You would have noticed. If someone has used, you would have noticed, right? You can copy it. Yeah. Anyway, so these four are valid image coloring formats. Okay. Okay, I guess I'll come back to this later. Okay, let me go through this question. So suppose A is a matrix. A and B are two matrices. The first one is of dimension n cross n, 2n cross n, and the second one is of dimension 2p cross 2p. Now A is skew symmetric and B is symmetric. So now I am doing convolution of B with A. Assume B is the filter and A is the image. So, and I get a resultant image C when I do this. So what would be the sum of all elements in the resultant image C? Mm. I'll give a minute. Maybe you guys can think about it, and if anyone, even if not the final answer, if you have a thought process, I mean, you can just tell me the line you have thought, and we can go over the answer. Like just think what happens when you multiply a skew symmetric matrix with a symmetric matrix, and the what would its resultant be? Like any properties of that. Okay, firstly, How many of you guys are aware about symmetric and skew symmetric matrices? Like, what is the defining property of a symmetric matrix? Someone. A transpose equal to A, right. And skew symmetric? A transpose equal to minus A. Okay. Um, so if I multiply a symmetric matrix with a skew symmetric matrix, what would happen? Any more properties of skew symmetric matrix? Like, what are the other ways you can define a skew symmetric matrix? One is A transpose equal to A transpose equal to minus A. How would its eigenvalues be? How would its diagonal structure be? Anyone? So what would be the diagonal elements of a skew symmetric matrix? Hmm? 0. And why is that? Hmm? Mm-hmm. Yeah. So if I have, say, an element, the first element, say the value is k, and it transpose would also have the same element, and that is equal to minus a. So k and minus k, k is equal to minus k, right? In that sense, so it would be 0. And how are the off diagonal elements of a skew symmetric matrix related? They'll be negative of it, right? So if I have whatever elements I have in the upper diagonal, the lower diagonal elements would be symmetric in value about the diagonal, and the value would be negated of that, right? Okay, yeah, that's good. So now, based on this properties of skew symmetric matrix, now suppose, like, let's just break this question down, and so let's just think A is a 5 cross 5 matrix. A is a 5 cross 5 matrix, and let's just think B is a filter, right? B is a filter, so it's a 3 cross 3 filter. So suppose it's a filter of ones, okay. Now, is this a symmetric matrix? B is a symmetric matrix, right? Uh, so for a simple example, let me take A to be, okay, just assume A is a 5 cross 5 matrix, and with diagonal element 0, and the off diagonal elements to be 1 on the upper diagonal and minus 1 on the lower diagonal. Okay. Can someone just multiply and, based on this example, think through it and say what would the convolution of A and B be? Okay, for simplicity, let me just take this itself. So if you convolve A and B now, now both of them satisfy the conditions here defined here, right? So suppose I place this filter centered around this 0. Okay, what would the value of this be? I mean the output at the centered location. So I'm asking the location at 2 comma 2 of 2 C. What would it be? So you guys know how convolution works. This is a very simple convolution operation here, right? So I'm placing B at this center, this filter at this center, and then what is the value at that center? Well, that's what I'm asking. 0. Now suppose I place it at the original location, the top corner here. So what would the value of that be? So when I'm placing here, how would you do convolution when it's a 3x3 filter and I want to place it here? So how would you do it? So you have to pad it, right? So how much will you pad, and along which directions? Along each of the direction for a 3x3 filter. One here and one above, right? So suppose it was a 5x5 filter, then how much would you have to pad? 2 rows and 2 columns. Okay, yeah, that's good. So for when I'm to pad one row, okay, what would the answer be at 1 comma 1 if you place this filter? What would it be if I place B at 0? I mean the first location of that matrix. Okay, that's not so hard. So what is the answer if I place this filter here? It will be again 0, right? Okay, so there are like three unique locations here, I would say. One is fine, I check the center, the corner, and let me check an off diagonal element. Okay, so if I place this B at an off diagonal element, what would the answer be? And how much would you pad if I have to place it here? One row above, that's all, right? And what is the answer? Result in C. I want C of 1 comma 2. What would this be? What? 2. It is 0 padding. No, you will pad it with zeros only, right? If I'm padding here, I mean padding a row above. Are you sure? It will be 2. Okay. Now suppose I place it here. What would the answer be? C of 2 comma 1. Here. Here. What would it be here? It's the exact same way, just that I'm placing it on the second row, first element. So where will you pad here to compute convolution? on the left here, right? And so what would be the answer? -2. So do you see any pattern here based on these values which we computed? So if I have to, what is the question now? So if I have to compute what is the sum of all the elements in C, so what do you think it would be? 0. So and why does that happen? So this is q symmetric and this is symmetric. So any values which I compute at opposite elements, I again get the exact same values. And C turns out to be a skew symmetric matrix, right? So whatever value I get here, I get the same value here. So when I sum the whole matrix, I'll get zeros. And the diagonal value elements, I get 0, right? So the so the sum of all the elements in C is actually 0. Is that clear? And it doesn't actually depend on what the weights of, so I took a simple example here so that it's easy for you guys to compute, but B can have any values and A can have any values. So since all the elements in your input matrix A is 0, however you weigh them and sum them using any symmetric filter, you would still get the resultant value of the sum of all elements in the matrix C to be 0. You guys can try out with more complicated filters if you want to explore, but you get why that would happen, right? Based on this example, at least. If anyone has any doubt on this, you can ask me. Okay. So this is a very simple question, just a practice question for you to do convolution. So I have A and B, which are two sequences, and I want to compute convolution of A with B. So how would you do it? Okay, so what are the properties of convolution? Can someone say that? Mm-hmm. Yeah. Is it linear? So what does linearity mean? Is convolution a linear operation? It is. Why so? So define what a linear operation means. Yeah. So if I sum A and B, right. So I can scale these two matrices and then apply convolution or get the resultant and then scale them. They would still be the same, right? Okay, so can you guys tell me what the first element of the output would be? Like say C is A convolution B. Say give me the first element and last element and we'll just move on. So what would C be? What is the first element? Hmm? 1. What? Okay, so how would you can someone say how? The first element is a resultant of what two vectors? product and sum of what two vectors. So someone answered something, right? So what is the answer? First element is 1, right? And how did you get 1? Is it 1 or minus 1? Yeah, it is a multiplication of these 3 elements. But how exactly? So what is the size of C, by the way? So this is a 3, the length of the sequence A is 3, the length of sequence B is 5. So what is the length of sequence C? 5. And how would I compute? So there are 5 elements. At the first element, what do I do if I have to compute here? Because there are 3 elements in the first one and 5 elements in the second one. Is it just multiplying these 3 with these 3? Anyone? How exactly do you do this convolution? Do you have to use something called padding here because of the difference in length of the 2 sequences? We can flip the filter here, right? So what would happen to this? You flip it and then it becomes minus 1, 0, 1. And then what do I do? Pad the input here to make it size 5, right? 0, minus 1, 0, 0, 1, 1 and 0. So now I have both are 5 dimensional. Okay, so C is of dimension 5. At the first element, what two vectors do I multiply? So suppose I am placing this filter over this B. So if I have to place this filter, so I call A is my filter and B is my input. Okay. So what do I do in convolution? You take the filter, you slide through it, slide the filter on the input, right? You keep moving it, and at each every element you compute you perform the convolution operation, get the resultant. So this is the filter. I want to place it on B, the first element of B, and get my output. So how should B look like? So this is my filter. Now the filter is fixed, right? I'll use this same one throughout. I will just slide through it, right? Slide through B. So this comes from the filter. And what is the element? I mean, so how would this look like? So this is the center of this filter, right? If I want to place this over here, so I have two elements towards the right. Towards the left, I have nothing. So I'll pad it with zeros. So I'll pad it with two zeros, and then I have 1, -1, and 0 from the first element. So now what is the value here? If you multiply this and sum, -1. Yeah, I mean, yeah, and you can index it however position 0. Now at 1, what would the element have? So yeah, now we know how this filtering works like. So someone has to tell me what this 2 should be. So does this second part change here? One. Why? Okay, here, right? 1, -1, 0. Do you not have to pad? So currently I'm taking this as the input, this as the filter, right? So this is A here and this is B. So I'm doing it as B convolved with A. A is the filter and B is the input. That's what we did in the first element, right? So this was my input, this was the filter. So now tell me what the input for like string here, I mean sequence here should look like, and the filter should look like for the first element, as in at the second position. One -1, 0. Why is it 3 elements now? In the first case I had 5, right? So is this a 3 cross 3 multiplication or a 5 cross 5? Not 2, right? Now I'm placing it here. So I have one element here, and I'm placing the center of the filter here. So I pad it with 1, 0. Then I have 1, -1, 0, and pad it with another 0. Not another 0. Yeah, it would be 2. And the filter would be the exact same thing. The filter is fixed, right? The filter is something which I'm moving over the input. So the filter will remain the same. Now what is this? What is this? What is the output? -1. So for the second element, do I have to do anything? Like any padding here? So the filter will be the same. So once I prepare the filter, it is fixed throughout the convolution operation. But the input over which I keep operating depends on the location, right? for C of 2, that is at this position, right? So here I am placing. So yeah, it would cover the whole spectrum. So it will be the whole sequence. 1 minus 1, 0, 2 and 6. Right? Any doubts? This is a very fundamental operation, right, which you keep using in signal processing, image processing, convolution, like even in deep neural networks, everything. It's important that you understand this rightly. Why am I padding the filter? Yes, yes. Yeah, you can do it here. That is how convolution is defined. Okay, can someone say what would be the uh, vectors you multiply here? Minus 1, 0, 2, 6, 0. Yeah. Okay. 1 minus. That is fine. Okay. You guys can see my screen, right? Yeah. Anyway, so this is a simple thresholding operation where I have an input grayscale image in this case, and I threshold it using a value, and if anything that is greater than that value, I make it 255, which is equivalent to white, and the other regions are made 0. So I have this image. So can this thresholding operation be implemented as a linear filter? So what are the properties of linearity? You just said, right, like someone told me what the properties of linearity is. So can you take some example values of, say, image has so many values, right? Suppose the values in this image cover the whole spectrum starting from 0 to 255. If I pick some random pixel values and validate over this so can someone check if this condition is satisfied? Any guesses? What do you think it is? Any guesses? There are only two options, yes or no. How many of you think? Okay, yeah. Yes. Okay. If you say yes, then why yes? Why do you think it is possible? Say I have two elements in the I mean in this image, okay, input image, where the values are I say 150 at one location. Say at some g of 0 0, the value is 150, and at a g of 100 the value is 200. Okay. Now I have given this, and what am I doing by so 150 and g of 100 these are just some two different locations in the matrix and two different values I have. So what is the thresholding? G of okay, not g, this should be I, image values, image. So if I have these two here, so what is g of 0 0 based on the thresholding threshold? I mean threshold is 100, right? So what is this? 1. And here what is g of 100? 100 comma 100. So if I do I of 0 comma 0 plus I of 100 comma 100, I am doing an addition, right? What is this? What is the value of this? 200 plus 150, so the value is 350, right? Now g is a filter, right? I mean, so I'm checking if it is, if I can implement it as a linear operation. If I can implement, what is g? G is equal to image into some filter h, right? So I'm applying that filter, whatever that condition over this. It is, the value is 350, right? And so what would I get? I mean, because it's 350, it is greater than the threshold 100. So the output value is 1, right? But if I so on the left hand side, so based on these three equations, do you think it is linear? How? So here what have I done? I have summed the two input elements, and then I have applied the filter. I've got 1. Okay. Here I've applied the filter directly on the input elements. I've got 1 and 1. If it were linear, this should have been equal to this plus this, right? So I sum and apply the filter is equal to this. For a linear case, this should be equal to h applied over I of 0 0 plus the filter h applied over I of 100 comma 100. But is this the case? On the left hand side I have 1, but on the right hand side I have 2, right? My LHS is 1 and my RHS is 2. This is linearity property, right? Is this clear? These are like very fundamental things, so at least if you have any doubts of why this is like this, please ask me. Isn't this what linearity means? Right? I have applied the filter over individual elements on the right side. On the left side, I first sum the input elements, then I apply the filter. So all these, the first three equations are clear, right? It's pretty simple. But in this case, it is not. So that means that I can't actually implement thresholding as a linear filter. So if G is linear and A and B are two images, it should satisfy this condition. I sum the two images, apply thresholding over that, should be equal to applying thresholding over individual images and then summing them. So yeah, I took the one extreme of the example where the input elements were greater than the threshold. Here, say at some location, the value is 90 and at another location, okay, of a different image. Anyway, b of m comma n is 20. So in both cases, if I apply the filter over these individual elements, I get 0, right? But if I sum them, a plus b, then the value crosses the threshold 100, right? I get 110. So in that case, if I apply it over the sum, then I would get 255 or 1, whatever, which is not equal to 0, right? So it is not non-linear. Is that clear? What are the examples? So there are several filters which are discussed in this first week's content, right? So what are linear filters? Can someone give me a few examples? Like name a couple of filters. Huh? Moving average filter is a linear filter, yes. What about Gaussian filter? It's also linear, right? Yes. But thresholding isn't, okay? Okay, let me move on to the next one. So suppose I have this input image and then I am multiplying it with some filter, say it's a 3x3 filter, and the output looks like this, where I have shifted the whole image by 1 pixel towards the left. So what should this filter look like? Say this is 3x3. Fill me those values. So what should H look like? It's a 3x3 filter. Just take a few examples of how this H should look like try to guess it. Because I'm not changing any of these pixel values, I just want them to be moved one element towards the left. So how would the convolution operation is performed? So based on that, what should H look like? So it has 9 values, right? Can someone tell me what those 9 values should be like, look like? So you're saying all zeros except 2 comma 3 element, this one, right? Yeah, that's right. So why is it so? Hmm. Hmm. Yeah, so usually I'm placing this position over the the image location, right? And I would multiply all values and sum them. So I want to take the next pixel, which is towards the right, and place it here. So when I place this filter on the image, I would all these elements would be 0. It would take the next pixel towards the right and place it here, right? So this is what H would look like. Did everyone understand that? Anyone has any questions on this? So yeah, H would look like this. And so suppose based on this, what should H look like if I have to shift the pixels towards the top, one pixel to the top? Using the same logic, if you think through it, what would the other filter be to pick? Is it that hard a question after seeing this answer? If this will shift the pixels to the left, what would shift the pixels to the top? 1 in 3 comma 2, so it would be here, right? And what about shifting it to the bottom? Here. And to the right? Here, right? So this was shifting it by 1 pixel. So suppose I want to shift it by 3 pixels. What would you do? Or any, like if you have to generalize this, I have to shift it by k pixels. What filter size would you pick, and what would the elements of that filter be? Did you guys get the question? Shift by k pixels. Say shift by k pixels to the left. 2k plus, so size of the filter would be 2k plus 1, right? And which element of that would be so there would be only one non-zero element, right, with the value 1. That much is clear, I suppose, right? And which would be that, what would the location of that be if I have to shift it to the left? So H of what is 1? K plus 1 comma 2k plus 1. So this is the middle element, right, of the filter, and this is the last element along the columns, which would be 1. Yeah, that's right. Is this clear? So, I mean, suppose you have to perform these kind of geometric operations, where simple operations to over the image, at least you kind of know how to design your filters to achieve that, right? Fine, I'll go on. So, are you guys aware of histogram equalization? No? Was it not there in the first week's content? I thought it was. No. Okay, everyone says it. No? Really? So, none of you know histogram equalization, is it? It was there, right? Okay. Good. Okay, so for those of you who know that it was there in the lecture, yeah, so I have two input images here. Say I apply histogram equalization on this. Uh, do you think it will always enhance the image? So, would these two images both look better after applying it? It's a just binary question, yes or no. What do you think it is? Any guesses what it could be? So there are all these enhancement techniques, right? Linear contrast stretch, power law contrast stretch, all such things. Do all of them always, like irrespective of how the image would look, do these methods always enhance the images, or are there specific places where they would work well and fail somewhere? I mean, if every algorithm was working well everywhere, then life was simpler, right? Okay, no guesses. Okay, what about this image? Do you think it will enhance this? So, uh, is histogram equalization, can histogram equalization be done through filtering, as in be represented as a linear filter? So, my previous question here was, can image thresholding be implemented as a linear filter? So, suppose I ask the same question here, can histogram equalization, it's also an enhancement technique. So, can histogram equalization be represented as a linear operation? Cannot. Why? Why? Okay, yes. Right, yeah, you use CDF for histogram equalization, correct. Um, so, fine, yeah, that is right, it cannot be done, but in general, so based on this example, we saw that image thresholding can't be represented as linearity. So, in general, when I am performing linear operations, how is a filter defined? versus here when you try to do it, uh, how would you go about thinking what the filter should be if this is the operation to be done? Like when do you think that like that you can't design the filter? So this is the function, right, which I've given. So what in this, based on this, like how do you say that, can you directly say by looking at this function that a filter can't be decided? I mean, it can be designed. We did go went over this in a detailed manner, right? uh, so what is that specific condition, I mean, based on which you can say the filter can't be designed? Okay, fine. So in this case, uh, so when I have all these linear filters, like that moving average filter, Gaussian, all that, so you are designing the filter. The filter values are not really dependent on your input image, right? Like I don't care what the input image is. I can always do moving average. It's a 3 by 3 filter, whatever the kernel size is, with all values being 1. Uh, but here, the output value is dependent on the input pixel value, right? And also in the case of histogram equalization, you compute the CDF, and also that based on what the pixel value is at a particular location, your output is defined. So whenever it becomes a function of the input, like purely dependent on the function of input, you can't really represent it as a linear filter. In cases like Gaussian and all that, the filter values are not dependent on the input. Does that make sense? Okay. Anyway, so yeah, so this is my input image, and like this is how the histogram of this image looks like. Why does it look like this? Anyone? So what is a histogram? I mean, so I have a matrix with pixel values here. So how would I compute a histogram here for this image? I take all the values at each location, then see the frequency of every pixel value, right? How many times it occurs in the image. So it's a pretty dark image, right? Like I'm not seeing very bright values here corresponding to like pure white or anything close to that. So here, based on this histogram, what is the maximum element in this, maximum intensity in this, and like an approximate number of number for that? Anyone? Around 100, right? Like just be less than 100. Could be something like 95 or something, right? You have only pixel values in this range. So something around say 30 to say 95 or something. You have only these pixel values. So in histogram equalization, what we try to do is, so a characteristic of a good image is that it occupies the whole spectrum of the range allowed, that is from 0 to 255. Usually images whose histograms are spread out uniformly, especially those images look good, they have good quality. So what histogram equalization tries to do is to stretch the histogram so that you try to make it close to a uniform distribution. So that's why these pixels, which occupy a very limited range, are spread like this so that it occupies the whole range from 0 to 255, right? Here there are some pixels which have the element, I mean, which are purely white in the enhanced image, and there are some elements where you have 0 also, I mean some pixels where it's fully dark, right? So yeah, is this image better than the above image? So do you think the lower image is an enhanced image? Yes, right? So yeah, at least fine, the math part is okay, like even if you're not aware, but at least at a high level intuitively, if you have understood based on this, So what do you think would happen if I do histogram equalization over this image? So, like, can you guess the range of pixel intensities for this image? It's a pretty dark image, right? So how would it be? Hmm? Pixel? As in, like, there are a lot of dark pixels, is what you mean, is it? Right. Yeah. So it can be like very peaky, right? At some very few pixels, like close to zero, would have a lot of. I mean, the frequency of uh, low intensity pixels would be high. So the histogram would be very peaky, right? Which is very far from a uniform distribution. So that is actually a drawback of histogram equalization. If the histograms look very peaky and occupy very small ranges, it can't actually do enhancement. I mean, here also, I know it does occupy a limited spectrum, but it's still not very peaky. There's still a decent distribution of the pixels, right? Which you can stretch. But what happens here is this actually. So as you see here, all the pixels are peaked around just near zero, right? So because they're all so it the whole mass of histogram is concentrated around zero. Here what you are trying to do is redistribute the mass through the whole spectrum, but here this whole thing gets mapped to a pixel range here, and because the whole mass is mapped to just a higher intensity, it just looks like this, as in, yeah. So this is just, I mean, just being images being bright do not make them enhanced, right? This is an example of one such case. So those who know what histogram equalization means, uh, why does this happen? Like, why do these values get mapped to just a higher value of pixel, I mean intensity? So in histogram equalization, we have the image, and first thing is you compute the CDF of uh, the histogram of the image pixels, and then the output is mapped like this. So at the location ij, I take all the probabilities until the image intensity, like so. So if this is how, I mean 0 to 255, and this is the CDF I have, if my input pixel is something here, it gets mapped to this value. So if my input pixel is here, it gets mapped to this value. So that's how histogram equalization is done. So suppose I have a very peaky distribution, right, where my probability is very high for a very low image. So my CDF would go up like this. Okay, I don't know how to draw it here, but yeah, it would be very peaky rather than this kind of uniform distribution. So it goes gradually from 0 to 1 here, right? But in the case of the lion, say for a very small value here, say at 2 or something, it would get very peaky and it would saturate. That's how the CDF would look like. And when I take the value corresponding to that low value, it will corresponding to some very high mass, which is very close to 1. So all these low pixels get mapped to a value which is very close to 1, or equivalently very close to 255. So that's what has happened here. What is here? It got mapped to a very high value, and yeah, as most of the pixels are here, it gets mapped here and it looks this way. Any doubts on that? Okay. Yeah, so now if you guys know how to do filtering, right? You have an input image, and so you have a filter. So this is a moving average filter, right? Or even called as box filter. So I take this filter, I place at different locations in the image, and I slide it across. At each location I compute the convolution operation. So what is the complexity of performing this linear filtering? So suppose my filter size is m cross m, and then image size, it's a square image, suppose, is n cross n. So what would be the computational complexity of the convolution operation? M square into n square, right? And why is that so? Right. Correct. Yes, that's right. So this is how it is, right? So suppose this is my image, and if I have a 3 cross 3 filter, to get this output I would be doing 3 cross 3 number of multiplications, right? And totally I have n cross n pixels. So it would be m square cross n square. At each pixel there are m by n multiplications, and there are n by n filters, I mean pixels. Yeah, but can you do this more efficiently using much way less number of multiplications? Hmm? Okay, suppose I don't want to do all that. Can the exact same filtering, or are there, okay, take this case, a box filter, this specific filter only, can I make it more efficient here? It's nothing related to image processing. Can I make this simpler, like denote it in a simpler way so that I reduce the number of multiplications I do? Any properties of this particular matrix? Mm-hmm. And just replicate. Right. So separate this two-dimensional filter into two 1D filters, right? So there is something called this separable filtering, which many of these matrices which are generally used can be represented that way. So yeah, if I have this matrix and I take this vector which is just ones, or in the case of Gaussian 1 to 1, so I do this filter, I first apply it horizontally, then I apply the same thing vertically, I did get the exact same thing, the same final result, I mean. So why, but can all filters be represented this way and made more efficient? So there are some custom filters, right? I mean specific filters which I'm showing here. But suppose I just pick random numbers into those 9 positions, a 3 cross 3 filter. Do you think I can make it more efficient in this way, like make it separable? So what is the defining factor of this separability? Like by looking at these matrices, what is one common thing across these matrices? They are symmetric about diagonal. Are they? Are all of them? What about this? This isn't right. Yeah, but it's still separable. Uh, think along the lines of dependency. Like, is this linear, the rows dependent, independent? What is the rank of these matrices? Anything along those lines? So, what is the rank of this matrix? Are the rows dependent in this matrix? The rows are dependent, right? They're all the same. So, and what is the rank in this case specifically? It's a very simple matrix, right? 1, right? And in this case, 1 again. Here, hmm? It's again 1. It's again 1. Here, same. Here, same. So all these are rank 1 matrices. So how how do you represent a rank 1 matrix? So suppose I have matrix H and I say it is rank 1. You can always write it as UV transpose, right? Like as a product of two 1D vectors. So and these two are the ones. So this is how you can decompose these filters as the rank 1 matrices. So as long as you can write them in this form, they are separable and you can make it more efficient. So yeah, fine. Now I told you that they are separable. Now what is the compute required? So earlier it was m square cross n square. Now for each pixel, how many multiplications do I have to do to get the final output? M. So what are my dimensions? I mean I have n cross n pixels. So okay, let's just do the break. At each pixel, how many multiplications? M. But by doing M, I'm only doing the horizontal one, right? Hmm. Yeah, yeah. So one, I have to do it horizontally and I have to do it vertically also, right? So there are 2m multiplications for every pixel. So there will be 2m multiplications and there are n by n pixels. So the total number of multiplications would be 2m cross n square. Make sense? So suppose I have to apply a blur filter, like a Gaussian filter, right? Here, something like this. This is a blur filter, right? If I first apply the horizontal filter, which is this 14641, this is how the output would look like. And then I apply the vertical filter 14641 in the vertical manner. After this, it would look like this. So that's the final output. I flip them. I do the vertical one first. I get this. And then I do the horizontal one. Then I get this. Both are the same. Versus I apply the whole Gaussian filter the usual way, the two-dimensional filter. I would go from here to here directly. So it is decomposed into a two-stage process, which is more efficient. Did everyone get that? Okay. So yeah, now you know what separability means, when a kernel is separable, all that. So given this matrix, is this filter separable? So what is the check for separability? What is the check for separability? So based on that, can you tell me if this is indeed separable? What did we just discuss here? What makes this filter separable? It's a rank 1 matrix. So all you have to do is check if this is a rank 1 matrix. It's not a rank 1, right? What is the rank of this matrix? By looking at the rows, what can you say about the rank? Hmm? Rank is 3, right? They are not dependent. I can't express any row as the other one. So it is not a rank 1 matrix, so it is not separable. Yeah, so how do you check that? I mean, different ways. If you can write it as an outer product as UV transpose, which is, I mean, if it is a rank 1 matrix, and if it has only one non-zero singular value, by checking any of this, you can indeed check if a kernel is separable. Okay. Anyway, this is fine. So yeah, there was a small bit on the frequency transforms and all that in the lectures, right? So what do frequencies in an image actually mean? So and how would the frequency spectrums of these image look like if you had to visually describe it to me? How would you describe it to me? So in an image we have two kind of frequencies, like one is horizontal ones and vertical ones. So let's just take the first image. So does this image have any horizontal frequencies or not? Hmm? It doesn't have, right? Why does it not have? There is no intensity change along the x direction, right? If I pick any position vertically and I scan through the line along x axis, it doesn't change, right? So it's the exact same value I see through it. So there is no change in pixel values when through in horizontal direction, so it does not have horizontal frequencies. What about vertical frequencies? Does it have? So if I scan a line vertically like this, do the pixel values change? Do the pixel values change? So as I'm scrolling, just follow my pointer along that way, are the pixel values changing? Anyone? I'm not even asking about the frequencies. It will change, right? It's going from white to black and so on, so the image values are changing. there is change in intensity, so it will have vertical frequencies. uh, in all cases look okay. As you can see, the frequency is changing 4, 5, 6, 7, 8, 9, 10, whatever. So how would the frequency spectrum look like? Is there just one frequency or more than one frequency in this? What is the rate at which it's changing? Like, does it have only one frequency component or more? How would the plot look like? The magnitude spectrum of in the frequency domain. It would look something like this. So there is only one frequency, right? So it is, and these two dots are because the frequency spectrum is symmetric about the origin. So that's why you see it as mirror image. But for reality, there is only one value, right? Like you see, it's like a wave with a particular frequency. The rate of change, I mean, the wave's frequency is this f. So it has only like a single frequency, and uh, so and these frequencies are increasing, right? So that's why you see the width in separation, meaning the frequency is higher. Like if this is my origin about the x-axis, the frequency is higher here compared to the first one, right? So that's how it would look like. Now suppose instead of this, if I had an image, so this is horizontal stripes, right? So suppose I had vertical stripes, what would the spectrum look like? Hello? Sorry, I lost internet, I think. When did you guys lose me? Hello? Okay. When did you guys lose me? As in, what was I talking when I got disconnected? Hmm? Ah, yeah. Yeah, so I flipped these input images so that uh, the stripes are vertical. In that case, would there be horizontal or vertical frequencies? Oh, yeah, my bad. You can see it now, right? Okay. So suppose this is the image. How would the frequency spectrum look like? horizontal, right? You'll see those dots on the horizontal ones. Right. Now, suppose I, okay, I'm not very sure of this, but as far as let me ask the question. So I rotated this by 90 degree, right? So instead of 90 degree, suppose I rotate it by what 45 degree angle. Okay. So make the image look like this. So say this is how my image looks like. Would this have horizontal frequencies or vertical frequencies or both? Both, right? Like if I scan a line this way in the horizontal direction, I see pixel values will change. And if I scan a line in the vertical direction, even then pixel values change. So it does have both horizontal and vertical frequencies. That does, right? But how would the spectrum look like? Stay. So in this case, what we did, I mean, if I rotate the image by 90 degree, the frequency spectrum also rotated by 90 degree. But suppose if I rotate it by 45 degree, what would happen to the frequency spectrum? Even that actually rotates by the same degree. So any image rotation equivalently, the frequency spectrum also rotates by the same degree actually. So this would go to change by 45 degree, and as in, so it would be something like this, right? And that would be okay, whatever. That would say that I mean you have both horizontal and vertical frequencies, right? In that case, because it is not on either the x-axis or y-axis. It's somewhere else in the 2D location, so it means that it has both x and y components. Okay, there was one question which I had skipped. Yeah. So assume an image. Assume a 2n cross 2n image. It doesn't matter, just assume an image, and you have a patch. Yeah, a patch operator that computes the average of p cross p patch of the image. And so how many different patch operations does the value of the cell n comma n contribute to? So you have an image, and so what is this patch operator? Like, can someone define what this filter would, I mean, what this p cross p matrix would look like if it is computing the average of the patch? Say p is 3. If p is 3, what is that filter? H. I mean, so this defines a filtering operation, right? That I'm averaging over each patch of the image. So what would that H be? You indeed have seen the filter in these slides today. 1 by 9, 1 by 9, right? It's just this, what? This box filter. This. So, yeah. It's this filter. Now, suppose, so I'm taking this filter and yeah, I move it across over an m cross n image. For how many pixels in this image, and I randomly choose a location, okay? So say this is my resultant image, and I pick some value 10 cross 10, like a location 10 cross 10, okay? So okay, no, 10 cross 10, it's okay. Yeah, so I pick the element 10 cross 10 in the image. So for how many elements, I mean how many convolution operations does this pixel contribute to if this is my filter? Is the question clear? I'm not sure if my wording was good enough. For how many output elements, say R, say the operation I'm doing is R is equal to I convolved with H, and I pick an pixel element at the 10 by 10th location, 10 comma 10 location in the grid. For how many elements in R does I contribute to? Does I of 10 comma 9? Yeah, that's right. Why? Each time the filter will come over that pixel, right? So where is that? And what are those locations? Like, so for what all locations would this I of 10 comma 10 contribute to? So if say I of 10 is something like here, this position, right? So will this contribute to an output that goes here? It will be the neighborhood, right? So if this is my pixel, when my filter is centered here, also it would contribute. When it is centered here or here or here or here at any of these neighborhood locations, this pixel would contribute, right? So if I have to generalize this, what would so I of xy contributes to what all locations? It will go from x minus, for this 3 cross 3 case, it will go from x minus 1 to x plus 1 and y minus 1 to y plus 1, right? Does that make sense? And if I have to generalize it to a different filter of any size, what would that be? Yeah, if it's a 5 cross 5, then it is minus 2 to plus 2, right? Yeah. Mm-hmm. Yeah. Yes. Yes, yes. So usually we do apply padding because whatever filtering, I want my resultant image to be the same size in most applications. So the common case is where we assume, by default you can assume that I want the resultant output to be the same, like even in this image, right? So the pixel values are right here, but okay, yeah. So anyway, I'm not sure about the example, but yeah, you get it right. You can always safely assume that you want the resultant to be the same size, and you do the padding accordingly, and all calculations are also done that way, right? So I want to suppose I want to like brighten the image, like increase something, all this, like get an apply and get edges of the image. I can represent all these as filters, right? Like Sobel and all can be represented as this, but I don't want my resultant image to be smaller image, right? I want it to be the same image as my input, if you think about the application wise. So you do the padding so that you have your resultant image to be the same size in general. Like I have many denoising filters, smoothing, averaging filters, all of this. I don't want my image to become smaller. your assignments are usually graded, right? If in case you have questions on the question, I think there is a forum where you can post these, if I'm not wrong. Yes, yes, yes. You can post there. Like so, any of the one of our the TS would look at it. There are also dedicated TS for the course apart from we who take the sessions as well. So usually someone would respond there. I think. But after the assignments are graded, because they are graded anyway, you can ask us in these sessions. So beforehand, if you do, I mean, then it's graded assignments, right? So it's not good to do that. But once it's done, you can ask us if you have any questions or any concepts to be clarified and so on. Okay. Oh yeah. So 7:45 already. Yeah, I kind of covered all the. Do you guys have any questions on whatever we discussed till now in this? Hello. Was someone saying anything? I mean, someone started saying something, but I lost that. Okay, can you put it in the chat? I'm not able to hear you, whoever is speaking. So, okay, you guys have no doubts then. So, how was this session? Like, did you find these discussing these kind of questions I mean, informative? Like, or do you want me to do something different, like cover some content from the lecture, or follow the same format for the next week? Different content. Other what kind of content? Different content apart from what is taught in the course. Or do you want me to cover something that is in that week, like pick some specific uh, kind of difficult topics from that week's content and discuss it in detail here if you can't follow the videos in that? I mean, okay, okay. Okay, yeah, maybe I'll plan that from next week. I'll pick one or two topics which I feel could be a little difficult in that week and present it, like cover that in a bit detail for the first uh, half an hour, 45 minutes or so, and then discuss some questions. Is that fine? Like maybe I can try that next week and we can refine it also. And if you have anything specific, so I'll pick whatever I feel is difficult for that week and cover, but you can ask me questions over over any of that content from that week at least. I think so. Anyway, so there are these code notebooks also released for this course, right? How many of you guys have went through it? So I plan to even go over that a bit so that if you have any queries during coding or solving assignments, it might be helpful. So maybe for the next 15 minutes, I'll just do that for today. So how many of you guys are like absolutely new to Python? Or can I like skip over this simple exercises part and anyway, the first notebook, I don't know if it's week 1 or like week 0 content. This one is a lot about the built-in operations in NumPy, how to do different matrix operations and so on, right? In image processing, the most normal operations like filtering are all expressed through matrix operations, right? It could be like flipping, doing matrix multiplication, all such things. how do you index your arrays, all such things is kind of covered in this notebook. So, e- yeah. So, yeah, one thing is rather than doing zero padding, when you do zero padding, suppose you have a border like white border, and if you do padding, because it would be you are padding it with if you pad it with zeros, the value would reduce down, right? Which you might not want. So one thing which people do is actually repeat the last value when they're padding rather than performing zero padding, so that this kind of artifact won't be introduced in the edges. But it's a choice to make and do it. Hmm. Yeah, it could be either it's a preference, and I think yeah, in where we are specifically doing these operations, like just simple applying simple filters, I think adding the like repeating the value would be better so that it doesn't introduce these kind of artifacts. But as convolution operation, when it is used in what I mean, like defining CNNs and all such things, because they are learnable filters and so on. Like the most commonly done thing is actually repeating the, I mean, padding zeros and uh, perform convolution. Because there it's more like hierarchical learning, right? It's not like you're extracting all the image content in one go, so it works fine. Okay. Okay, yes, you can see my screen now. Okay. So, are you guys familiar with these packages like matplotlib, numpy, skimage? So, skimage is, I mean, it's a library which deals with a lot of image operations: read, write, show them, perform operate. I mean, perform a lot of enhancement techniques and so on. PLT is a matplotlib library where it's a display library basically. So, yeah, what is the data type of these values that are stored in an image? So it's an array, and where each array element is of type what? Hmm? Unsigned intent. Yeah, and it's an RGB image, so you have three dimensions, three channels. Now let's visualize how the three channels look like. So these show the red, blue, and green channels. So in this case, what would the dimension of this image be? How many channels does it have, you think? Single channel, right? It's a binary image which has just zeros and ones. Yeah. Yeah, so this is the intensity plot in a 3D manner. So can you guys see the horse here? Like here. So it's a binary image, right? Which has the values 1 and zeros only. So the zeros correspond to the horse region and 1 corresponds to the background here. So how do you implement this simple? Yeah. So if I have to plot the image, if you think the most simplest way to enhance an image is to just add a few intensity values, right? Like just shift the intensities towards the right. So all these can be implemented by simple matrix operations, like I am shifting it by say 40 intensity values, and here if I have to flip rows, so yeah, this is how we can flip rows in the. So this is my last dimension, right? In the height and so the rows correspond to the first dimension and columns correspond to the second dimension. So this is how you flip the rows and columns this way. So I want the x-axis values to be the same, y-axis values to be the same, and the x-axis is reversed. The indices are reversed. So what are point operations? So what point operations and local operations. So what are point operations? So point operations are anything which depend on the individual intensities. Like in this case, where I'm increasing the intensity, right? At every pixel location, I'm just increasing the intensity. So at every point in the image, I'm doing something, and it doesn't matter. I don't depend on the neighborhood there, right? So these are point operations. So applying linear contrast, stretch, all these are point operations because I uh, it only depends on the single value. So this is the negative of an image. So how do you compute the negative of it? Just do 255 minus the pixel value plus 1. So what is linear contrast stretch? Can someone explain what the function is mathematically? Hmm. Maximum and minimum, which I can represent here, right? Which is 0 to 255. So I compute the min and max of the image. So in this case, the minimum is 61 and maximum is 250. Now I will stretch it to the maximum values which the image can hold. So this, yeah, so 250 is the max that can be represented in an 8-bit image, and 0 is the minimum, right? So this is how I would do linear contrast stretch. So this is image minus its min by image max minus image min into the whole range. So by this will scale it to 0 and 1, and then I multiply it with by the range, the spectrum 0 to 255, and yeah, plus I min is the offset in this case, which is 0. So yeah. So when does, okay, fine, linear contrast stretch has it done anything here? Does it look like this image is has higher contrast? By the way, really? Is this take? Now I think it has, but earlier I'm not sure. So usually there is this one issue with when you're using this display, right? Like plt.im show, it doesn't really show you the it always does the linear contrast stretch and shows you. Okay, I know. I put this here. Yeah, can you see my screen now? Hello? Okay. Sorry about that. I had some internet troubles today. So yeah, I think there is this mistake in the notebook. This is something you have to be careful about, especially when you are using these notebooks and running it using the matplotlib library. So this was my input image, and this was the linear contrast stretched image, right? And then I am displaying it. Both of them look the same to me actually. Someone said it looks different, but it actually doesn't. They look identical. Then in this case, I've set what the minimum and maximum value should be, and this is how the image looks like. So this is actually my input image. If I can open the file, so that happens because the plt.im show usually does linear contrast stretch and displays it. So even the initial image, it was actually showing the same. So when you are looking at it, you should actually specify what its min and max value should be, so that it displays the, I mean, with respect to the whole range rather than performing linear contrast stretch automatically. So this is my input image, and this is the result after doing contrast stretch. So yeah, you can see that the values are scaled, right? It is 0 and 255. Yeah, so this notebook has other filtering operations like doing moving average filter. So yeah, so given the window size, how do I compute padding? I would have to add, so for 15, I would have to add how many? 7 towards the left and 7 towards the top, right? So it is window size minus 1 by 2. So my output array should be of the same dimension. So I initialize it to zeros and I pad it with that size given the input. So now my initial, yeah, this is my padded image. So this pixels are padded ones, right? Like padded with zeros. And then I compute the moving average. So the moving average window is actually the mean, right? So I iterate over the image, take a patch, then compute its mean and place it at ij. So this is how it would look like. Okay. I guess I'll end the session now. Uh, it's there in that GitHub site, right? Like the project site. There's one GitHub site for the like course. Okay, I'll share it here in this chat. Can you guys access it now? So it has all the slides, lectures, and these code notebooks also there. Okay, then. Thank you, everyone. Yeah, so for next week, I'll prepare pick some topics, discuss that for the first half maybe, and then discuss a few questions and go through the code notebooks in the later half. Okay, if you have no other questions, I'll end the meeting. Thank you. Yeah.